Now, in previous lecture, I told you IVP. So, one exam, I am doing one more example on IVP. After that, I will start differentiability. Let you have a function from R to R be defined as this is fx is equal to 1 if x is greater than 0, minus 1 if x is less than 0. Question is, check the applicability of IVP. If not, why? If not, here f x is greater than is equal to 0. If x is greater than 0, function is 1, x is less than 0, function value is minus 1. So you can take any value. You can take f minus 1. This is minus 1, which is less than 0. You can take f minus 2, f minus 3. It is up to you. No problem. And positive at every x, every value of every positive value of x. So you can take anything. So here I am taking 1, you can take 2, 3. Yeah, here you can take 1 by 2. It doesn't mean. Main thing is you are getting negative and positive. So here you can write this is f minus 1, which is this. I'm writing like that. This 0 is less than 1 by 3 is less than, you can write that minus 1 is equal to f minus 1, 1 which is equal to f1 by 2. So you can write it like that. So here 1 by 3 value lies between f minus 1, f1 by 2. But there does not exist x naught in R such that value of f x naught is 1 by 3. That means IVP is not applicable. It does not satisfy IVP. IVP is not satisfied. Now problem is why it is not satisfied. Problem is there is one condition, f must be continuous. This function is not continuous. Why? Since f is not continuous. So be careful. If f is not continuous, then IVP, it is not, then IVP fails. This is the example. There are a lot of examples. So for IVP, f must be continuous, and then if it exists like that between any two value of the function, there exists a point. Suddenly value of the function at that point will be the x, whatever you are taking, y or whatever. So this is the why IVP fail here, because f is not continuous. You are not getting. Is it clear in this question?
Yes, sir.
Okay. Now
Yes.
come to the okay. Now come to the differentiability. You know what is differentiability? But I am giving a proper definition. It says let I be an interval which is not a singleton set. Okay. Let f be a function defined on I. Now I say f is said to be differentiable. F is said to be differentiable at a point at C if you know two things. If left hand derivative, this you can write C, limit h is tend to 0, f c minus h minus f c over minus h. This is denoted by left c, and right hand derivative, this is denoted by limit h is tend to 0, f c plus h minus f c exist. These exist, and if they are equal, if right hand derivative and left hand derivative are equal, and this is denoted by f dash c. So f, or you can say f dash c is called derivative of f at c. So this is the left hand derivative, right hand derivative. In some books it is written like, or in another way, how can you write? This is limit f dash c, f is differentiable at c if f dash c, this is limit h is tend to 0, f c plus h minus f c, this is h exist and unique. We also write like that. Or okay, if x is equal to, you write c plus h, so you can write this is h is equal to x minus c. So here you can write this definition, limit h is tend to 0. So this is h is tend to 0. So you can say like that x is tend to c. The limit x is tend to c. This is fx minus fc over x minus c exist and unique. So in some books it is also written fx. We can write f dash c is equal to limit x is tend to fx minus fc x minus c. So it means if f is differentiable, so you need to check that right hand derivative, left hand derivative. If they are equal, then f is differentiable. Yes, sometimes you can check in this way or also. Now I am doing one theorem. You know this theorem. Every differentiable function is continuous. Let f be defined on an interval I if f is differentiable at a point C, then f is continuous at C. If it is differentiable, then this is continuous. So proof I am doing, proof is one line proof. Let x is tend to C and x is not equal to C. So what is f x minus fc? So you can write f x minus fc divided by x minus c and x minus c. Taking limit as x is tend to c, so this is becoming limit x is tend to c fx minus fc. If you take this will be limit x is tend to c fx minus fc x minus c into limit x is tend to c x minus c. If you do this, this f minus c, this will be f dash c into 0, this is 0, x is tend to 0. So here limit x is tend to c fx is equal to fc. So here you can say f is continuous. So every differentiable function is continuous, but converse is not true. It means it is possible that function is continuous but not differentiable. You can see example 1. Suppose fx is equal to mod x. So you can check at 0. Clearly, I am not doing f is continuous. At 0, differentiability. At 0, let us check. F dash 0, you can check by right hand derivative or left hand derivative also. I am doing directly f h minus f0 over h. So this is limit h is tend to 0 mod h over h. So here f dash 0 will be if, sorry, this will be 1 if h is greater than 0. If h is less than 0, this is minus 1. If you are, what is this? H is tend to 0. It means this is actually right hand derivative. You can find from by definition of right hand derivative, or this is actually left hand derivative. So right hand derivative or left hand derivative not equal, f is not differentiable. Yeah, you can say value of dash 0 is not finite, not unique. So quickly you can say f is not differentiable at 0. So here function is continuous but not No, Kartike, you cannot prove by graph. You will say, sir, there is a cone. So you don't know the definition how.
So your voice is making. Sir, you should rejoin.
Just wait, wait. I'm doing these things. Now my voice is coming or not?
Yes, sir, clear now.
Yes, sir, clear now.
Yes, sir.
Okay. Sorry. Yes, this is Kartike. You can see this graph. You will say that this is continuous, but here, how you can prove that this is not differentiable at 0? You need to show some mathematical calculation. You cannot say directly if cone occur, it is not differentiable. Okay?
Okay, okay, sir.
By graph, you can show this is continuous, but differentiability, I agree with you that if there is no smoothness, it is not differentiable. But you here in this course, you need to prove that. Okay, if there is cone, then the function is always not differentiable. Okay. Now example 2. Suppose you have a function like that. I have done this function x sine 1 upon x 0. If x is not equal to 0, x is equal to 0. So again, I have done this question continuous at 0. This is continuous at 0. I have done. Now differentiability, I am doing this by right hand derivative or left hand derivative. So that right hand derivative, this is r f dash 0 limit h is 10 to 0. This will be f 0 plus h minus f 0 by h. So this is limit h will be cancel out sine 1 upon h. Again, does not exist. Right hand derivative does not exist because value. Same thing you can write left hand derivative limit h is 10 to 0 f0 minus h minus f0 over minus h. This will be limit h is 10 to 0 minus h has, so I think it will be sine minus 1 upon h. Again, does not exist this limit. So here f is not differentiable, but f is continuous. So here I did two question where function is not differentiable, but function is continuous. So let us do one more interested question on which is based on differentiability. Let f0 is equal to 0 and this f dash 0 is equal to 1. This is given for a positive integer say k, find the value of this function, this term, fx plus fx by 2 fx by 3 plus fx by k. What is given? This is given only. No, we do that when taking limit in terms of x rather than h. What you are saying, Karthik? Pulkit, it should be limit h. Can I check? Did I do some mistake?
नो सर, ही वाज सेइंग दैट उसमें लिमिट एक्सटेंड्स टू 0 प्लस लिखना होगा, तो वही।
Akshat, is it clear?
यस सर, इट इज क्लियर।
सर जो अभी आपने लिमिट h टेंड टू 0 साइन माइनस 1 बाय h लिखा है, सर वहाँ ऑसिलेट बिटवीन -1 to 1 लिखना है या सर डज नॉट एग्जिस्ट लिखना है?
Does not exist लिख दो या oscillatory a finite value oscillatory a finite value lies between -1 to 1. एग्जैक्ट लाइन ये है।
ओके सर।
और लिमिट मैंने लिखा डज नॉट एग्जिस्ट, मतलब लिमिट डज नॉट एग्जिस्ट। ओके
सर
here come to point this question was this. So here two things are given, value of f at 0 and the first derivative at 0, f dash 0. So he is saying find the value of this. The idea is you need to calculate f0 f dash 0. So what I am doing, solution, I will do some simplification. 1 by x fx plus fx by 2 plus fx by 3 plus fx by k. Now I am writing first term. This can I write? This is limit x is tend to 0 fx minus f0, because value of f0 is 0. Bhargav, it is okay. fx minus f0, or you can write like that x. Okay. Why I write? Because if write in this way, so I know limit x is tend to 0 x minus 0 fx minus 0 x minus 0. So this is f dash 0. I am applying this limit, I think x is tend to c fx minus fc x minus c definition. Clear? Now second term I am writing here. First I explain how I am writing this. This is limit x is tend to 0 fx by 2 upon x. So can I write minus f0? Now here you can write this is 1 by 2 limit x is tend to 0. This is equal 1 by 2, or this is f x by 2 minus f0. You can write x by 2 minus 0 multiply by 2. Now, and you can write if x is tend to 0, so you can write x by 2 also tends to 0. So finally you can write 1 by 2. This is equal to 1 by 2 limit x by 2 0 f x by 2 minus f 0 over x by 2 minus 0. This is f dash 0 actually. So here what can I write? 1 by 2 limit x by 2 tend to 0 f x by 2 minus f 0 over x by 2 minus 0. This is the thing is, if there is x by 2, here x by 2, 1 by 2 will be outside. Or what is this? This limit is actually f dash 0, where x is replaced by x by 2. Now, what will be the third? I am writing 1 by third, because 1 by 3 you need to take common, limit x by 3 tend to 0 f x by 3 minus f 0. This is x by 3 minus 0, and so on. Finally, this will be 1 by k for last term. Limit x by k tends to 0 f x by k minus f 0 x by k minus 0. If anybody has doubt, ask me in this expression. This is important, otherwise nothing in the question. Now limit x is tend to 0 1 by x fx plus fx by 2 plus fx by 3 plus fx by k. Can I write this is first is f dash 0, second will be this is f dash 0 plus 1 by 2 f dash 0, 1 by 3 f dash 0 plus 1 by k f dash 0, or value of f dash is 0 is given 1. 1 plus 1 by 2, 1 by 3, 1 by k. So this is the answer. If anybody else ask, yes,
So एक्सप्रेशन एक और बार बता दीजिए मतलब
bata. I'm just, this is many. What I am doing, first is fx. See the fx. Here I am writing actually. First, I am using this definition. Limit x is tend to. So from first expression, what you can do, limit x is tend to 0. Here c is 0. It is c. Okay. So here fx. So fx you can write f0 because value f0 is 0, or this is x minus 0. So this is equal to your f dash 0. So first is okay.
yes sir.
Now second. Second, what in second expression, what you have, limit x is tend to 0 f x by 2 over x. So first divide by 2, here divide. So 1 by 2 will be common. So limit x is tend to 0 f x by 2, यहाँ होगा x by 2. Again you can f0 because value of 0, but it should be same as here. These three things should be same. So I know if x is tend to 0, so x by 2 भी tend to 0 होगा. So I can write x tend to 0 या x by 2 tend to 0. It doesn't difference. So it will be limit x by 2 tend to 0 f x by 2 minus f0 x by 2 minus 0. और ये क्या है? ये तो डेफिनेशन हो गया ना, x इज रिप्लेस्ड बाय x बाई 2। तो ये जो डेफिनेशन है डिफरेंशिएबिलिटी, इट डजंट डिपेंड अपॉन x, इट इज f डैश c। तो यार f dash 0 again 1 by 2
Clear?
means whatever you have here, it is y x z कुछ भी हो, ये z है तो यहां भी z होना चाहिए, और ये z टेन टू 0 होना चाहिए, कोई भी z।
Clear, sir.
गेटिंग पॉइंट और नॉट?
Yes, I get it.
एनी अदर डाउट? Okay, now so differentiability is over. Now local maximum minima I will tell you after 2 lecture. Before this I am going to tell you the application of this. Actually application of this is Rolle's theorem, mean value theorem, local maxima and minima of this. So first I am going to Rolle's theorem. So first I am writing the statement, what it says. Be careful, read carefully. Let f is a function on closed interval. Be continuous on AB. Closed interval and differentiable on open interval AB. It says and if the value of the function at end point same, it says then there is C, 1 point AB, that is A is less than C is less than B, such that how f dash C is equal to 0. It may be more than 1. There is C. I didn't write at least C या 1 C. There is at least you can use. But एक C होगा, at least 1 होगा. So that's why if you write there is C, so it is silent at least 1. Such that value of C is lie between A to B, such that f dash C is equal to 0. If f is continuous on closed interval, differentiable on open interval, and if f is equal to fb, so there is some C such that there is some C in open interval AB such that f dash C is equal to 0. What is the geometric interpretation of this? Suppose you have x and y, and you have this graph. You can start from here also. This is, doesn't mean f is equal to fp. I want to show you that is. Suppose this graph is starting. This point is A or this point is B. This is FA or this is FB. So here FA and FB are same. This is graph of F. So what it says, if F, this is continuous, this is differentiable. Now, if fa is equal to fb, this is like that, fa is equal to fb. There exists a point like this. The tangent at this point, there exists a point, the tangent, there exists a point C between A and B, this is C1, that the f dash C is equal to 0. F dash C is equal to 0 means, what is this line? This line is parallel to the x-axis. It means there exists a point between A and C such that the tangent at that point will be parallel to the x-axis. This is C1. Or if this is a graph, you can write this is there actually one more point C2. This is you can write C3. There may be one or there may be more than one. The tangent at that point will be parallel to the origin, parallel to the x-axis. Is it clear geometric interpretation? Yes or no?
Yes, sir.
Yes.
Okay.
Yes, sir.
Now let us take some example on Rayleigh's theorem. First is question is check the conditions of Rayleigh's theorem in the following questions. Bhavya Gupta, mute your mic.
Yes, sir.
Questions. So let us take some questions. Some suppose A. First is I am taking this. I have done this question. Second, I am taking this. Fx is equal to, you can take this is third is this. Fx is equal to cos 1 upon x and minus 1 is less than x is less than. So in first example, you can see x is the element. F is continuous, but f is not differentiable. At 0, even other two conditions are satisfied. F minus infinity, mod minus infinity, positive infinity, F positive infinity, positive, and F is continuous. So F is continuous and the value of the function at a point is same, but F is not differentiable at 0. That means Rayleigh's all the conditions are not satisfied. Two conditions are satisfied, but F is not differentiable condition is not satisfied. In this is a polynomial. F is continuous, F is differentiable, but F2, which is 4, is not equal to F3. This is 9. In this example, equality condition is not satisfied. Here, Fx of cos 1 upon x, even this is not continuous. So Rayleigh's theorem cannot be applied in all these questions. In one question, f is not differentiable. In one question, they are not same at point value of the function. In third, f is not continuous, so even f is not differentiable. So any one condition can violate. So if you are doing the question by Rolle's theorem, you need to check all the three conditions. Any condition can violate. If f is differentiable, if you have proved that f is differentiable, then you have no need to check continuity because every differential function is continuous. You can write this statement. Now, let us do one more example. Verify Rolle's theorem for this problem fx sin x over ex in 0 pi. So let us check. Clearly sin x is continuous, e raised to power x is continuous, so sin x over ex is continuous. So you can write f is continuous. You can write directly also in the exam that this is because sin x is continuous, ex is continuous, and ex is not becoming 0 at any point in 0 pi. So sin x over ex is also continuous. Second, sin x here both are differentiable and ex is not equal to 0. Same thing you can write f is differentiable. Now let us check third condition f0. So f0 I think sin 0 e0 this is again 0 f pi sin pi over e pi this is again 0. So it means f0 is equal to f pi. So in this example all the three conditions of Rolle's theorem are satisfied. So there must exist a c 0 to pi such that f dash c is equal to 0. So you need to prove f dash c. That means c, you have to show c value of c lie between 0 to pi. Now what is f dash x? Fx was I think sin x over ex. So f dash x this will be I think ex cos x minus ex sin x e 2x. So f dash c ec cos c minus ec sin c over e2c is equal to 0. E2c take right hand side. So finally if you take this will be ec cos c minus sin c, this is 0. But EC is not equal to 0. So this cos C minus sin C is equal to 0. So this is 10, C is equal to 1, or finally C is pi by 4, which is clearly C belongs to 0 to pi or 2 pi, whatever we 2 pi. So Rolle's theorem is verified. So this is all about Rolle's theorem. Is it clear? If anybody has doubt, ask me. Otherwise, today lecture is over. In next lecture, I will tell you mean value theorem, Cauchy, and then local mass. Yes.
सर वो एफ एक्स इक्वल टू कॉस वन बाय एक्स वाई एग्जाम्पल एक बार बता दीजिए सर वो कंटिन्यूस क्यों नहीं हुआ है
कौन सा?
सर इसके ऊपर वाला
Cos 1/x.
यस सर सर कंटिन्यूस तो होगा ना सर
अब होगा क्या?
सर मतलब डिफरेंशिएबल नहीं होगा
मतलब कंटिन्यूस भी नहीं होगा. Cos infinity.
सर मतलब इसका क्या आप 0 से 1 के बीच में ही कुछ बनेगा और उसमें एब्रप्ट चेंज नहीं आएगा
हाँ, -1 to 1 होगा. ये फाइनाइट वैल्यू नहीं है तो इट इज ऑक्सिलेटरी. द लिमिट डज नॉट वैल्यू ऑफ द फंक्शन डिफाइंड नहीं है 0 पे.
अच्छा
लिमिट एग्जिस्ट करेगी अगर जब लेफ्ट हैंड लिमिट राइट हैंड लिमिट एग्जिस्ट कर जाएगी.
नहीं 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 सर
तो दैट इज नॉट कंटिन्यूअस.
यस सर हाँ ओके सर
ओके, वेलकम, थैंक यू. एनी अदर डाउट?
सर प्रीवियस टर्म की पेपर शेयर कर देंगे
पेपर मेरे पे नहीं है प्रीवियस ईयर में.
ओके सर
सीनियर पे होंगे. यू कैन आस्क फ्रॉम सीनियर. और